Ever seen a cashier scan a barcode in half a second? On a wrinkled bag, a curved bottle, even a slightly scratched label? That instant beep looks effortless, but it's not. Barcodes are designed to survive messy printing, bad angles, and real-world damage. You've also seen them a million times, those random black lines on almost everything you buy. But one tiny detail makes barcodes readable at high speed, even when they're a little blurry. So why do they look like that? And why did this design become the standard? And it comes down to 3 simple tricks. First, clear markers that tell scanners where the code begins. Second, empty space that isolates the code from everything around it. Third, a built-in math check that catches mistakes. A barcode isn't random stripes. It's information turned into a pattern a scanner can read as a signal. Dark, light, dark, light. The scanner isn't reading bars like text. It's reading contrast changes at speed. That's why barcodes use different widths. Thicker and thinner bars, and the spaces between them, represent the numbers. It's a compact way to encode data, so machines can read it quickly. Here's the simple structure. 3 design problems barcodes had to solve. Problem 1. Scanners need to know where the code starts and ends. Problem 2. It has to work even if it's scanned the wrong way. Problem 3. It has to catch mistakes fast. First, why bars at all? Early barcode ideas go back decades, including a 1952 patent by inventors Norman Joseph Woodland and Bernard Silver. But the version we know today took off when grocery and retail needed something fast, reliable, and standardized. A barcode is basically information turned into a pattern of dark bars and light spaces. A scanner isn't reading lines, it's reading contrast. Dark, light, dark, light, like a timed signal. Now problem 1. How does the scanner know where the barcode begins and ends? This is why barcodes have special patterns called guard bars, fixed markers that don't mean a number, they mean you're in the right place. If you look closely at many UPC barcodes, you'll notice the start and end patterns look similar. They act like bookends. They help the scanner lock onto the code and read it consistently. There's also something even more important than the bars. The blank space around them. That empty margin is called the quiet zone, and scanners rely on it to detect the edges of the barcode. No quiet zone, and the scanner can't tell what's barcode versus what's just design noise. Problem 2. What if it's scanned from the other direction? At checkout, the barcode might be swiped left to right or right to left. So common barcode standards were designed so the pattern can still be interpreted even if the scan direction is reversed. That's one reason you see that center split in many UPC-style barcodes. It's not decoration. It helps the system keep its place and decode both sides correctly. Now problem 3. How do you catch mistakes? Because barcodes are printed on packaging that gets scratched, wrinkled, or smudged. So most retail barcodes include a check digit, a final number calculated from the others. If something is misread, the math doesn't match, and the system knows the scan is likely wrong. That's why a bad scan often turns into a beep beep try again, instead of ringing up the wrong item. So the design is basically a set of safeguards, markers to find the code, margins to isolate it, and math to detect errors. Now, why did barcodes win instead of some other design? Because they're brutally practical. They print well on cheap packaging. They can be read quickly. They work with simple scanners. And they scale. Once a standard exists, every store, warehouse, and supplier can use the same language. That standardization is the real superpower. A barcode isn't useful because it's clever. It's useful because millions of companies agreed to treat it the same way. So why did barcodes become the standard instead of some other label system? Because they're cheap to print, quick to scan, and easy to standardize across millions of products. Once stores and suppliers agree on one format, the whole system becomes more valuable with every new product added. And once that happens, everything speeds up. Checkout gets faster, inventory becomes trackable, reordering becomes automated, logistics becomes measurable. And that's why the first retail scan became a big deal. On June 26, 1974, a pack of Wrigley's Juicy Fruit gum was scanned at a supermarket in Troy, Ohio. Often cited as the first grocery item scanned with a UPC, that moment wasn't just a tech demo. It was the start of a system that made checkout, inventory, and logistics dramatically faster. Once barcodes worked at the register, everything else followed. Warehouses could track products. Stores could reorder accurately. Prices could update in a system without relabeling every item by hand. So when you see those stripes, you're looking at a design that solved a real problem. How do you identify a product instantly using a machine in a messy physical world? Answer: give scanners clear markers, protect the code with empty space, and verify the read with math. That's why barcodes look like that. Not because they're mysterious, because they're engineered for reality. Even the barcode on a cereal box has a story. Small facts, big stories.